Okay, hello everyone. Jacob Rahdarian here from SME Houston Chapter 29. Thank you so much for joining us today. I've been tasked with doing a CAD CAM overview in Mastercam and SolidWorks. Thanks to our great relationship with Detroit Chapter 69. Thanks to Farhad up there and his leadership team. And I would definitely be remiss if I didn't thank the Chapter 29 leadership team as well here in Houston for helping coordinate this behind the scenes. Just as a disclaimer, I'm by no means an expert in either of these softwares. I am certified in both since 2015. I've used Mastercam for over 10 years and SolidWorks for over 6 in various different contexts. I've worked in job shop and production environments, so I've programmed hundreds of components, conforming components successfully. And by virtue of SME and good network at National, they have allowed us to use the SME logo, which by the way is registered. So any unauthorized use of this logo is expressly forbidden. And if you have any questions, please contact Diana Helka at National, and I'm sure she could lead you in the right direction. So with that, I would also like to thank Brandon Coker here at AE Machine, as I'd run into some software difficulties, and he was generous enough to allow us to use his software and facility for the sake of providing you all with this useful information, I hope. And AE Machine is a tight tolerance facility. They're here on the northwest side of Houston, and they specialize in many different end users: aerospace, firearms, oil and gas, and industrial sectors, just to name a few. So sincere thanks to you, Brandon, and your team. Try not too much to encroach on your production. Without further ado, I'm going to go ahead and get started. If you could, please abide by some housekeeping rules. Please keep your microphones muted so everybody gets the best bang for their buck. And also safety. Let's keep in mind your points of egress. If you have AEDs, if you're on the clock, I think when this will air, just please keep that in mind. Lastly, before I begin, if you do have any specialized applications, I would encourage you to get with your local VAR or value-added reseller, who I'm sure you're purchasing these seats of software through. And if you get on now to mastercamu.com, now through the end of June, you can get free trainings to various aspects of Mastercam, whether it be 2D mill, 3D mill, or lathe intro. I would highly encourage you to take advantage of that while you can. So thanks again for joining. We'll go ahead and get the screen share and we'll get started. So we'll open up a new file, get this part file started. One thing to note is that it's important to determine which unit you are working in prior to starting. We're going to go with good old Imperial. And if you wanted to get, real deep into it, you could, select materials, get the right densities and so forth. But we're not going to get that far blown into it. On the front plane, we're going to go ahead and invoke the use of a sketch tool, very powerful sketch tool that I like, called Sketch Picture, which enables you to bring in a JPEG or PNG file. And again, please keep in mind, this is not for the purists out there. Basically, we're just going to go ahead and show you different, functionalities of sketch tools, and basically just a high-level overview is what we're aiming for here. So you might have noticed that I hit the right click and, or hold right click and drag over, and you get some functionality here. You can adjust that in the options setting, and I would encourage you not to use the 8 key one, because that gets a bit overwhelming, I think, and that kind of defeats the purpose of it, in my opinion. So we're going to just scale this thing down a hair, because we're going to import it into Mastercam and do some machining in a curved vise. So, we don't want to get too huge with it. And so now what we're going to do is just create a very simple sketch. We'll make this corner rectangle to encapsulate it all. In fact, we'll make another corner rectangle. We'll start here with the simplest bit there. And if you tap the A key, you'll notice that it brings me right into an arc, which is nice to have these type of quick keys where you can, quickly toggle between lines and arcs. Is very, very handy feature. And with these splines, the more points, the more refined it will be. So again, this is nothing, we're not aiming for perfection here, just trying to get this sketch going so we can extrude a solid model and get to putting some tool paths on it. So seeing as this is a duplicate portion of the letter M, would be a bit redundant and wasteful of time to do all of that again. So what we'll do is we'll right click on this and select chain. And so we will go to linear sketch pattern, and we will toggle this thing over, and we'll just get it close as we can. Maybe it looks like 1 inch 45 thou. Maybe let's try again. 48, just a little bit closer, maybe one more time. 49, very good. We'll go ahead and get the letter S done. You might notice that this thing is trying to take over and draw some associations from that construction line I created. So just go ahead and get rid of that. There we are. So what we'll do is we'll just go ahead and offset this whole chain. It's pretty close. And we'll cap it off right here. One thing was kind of a helpful trick is if you tap the G key, it'll come in and open this magnifying glass, so you can check if you have any gaps in your geometry that don't make a full chain. That would create some issues when you go to try and extrude it. Also, you could tap the space bar key and it gives you some quick access to various drawing views. Toggle the A key again, get this arc command back going for us. Let's say I don't like that. We're just going to stick with the spline. That's pretty close. You'll notice that we have a little line segment left over from that offset. So if you hit trim, we can go ahead and just lop that right out of there. And we'll connect this last 2 points. So we've got all of the SME done. Definitely do not want to omit the registration symbol. Let's create another arc out here. And if you click and shift and hold on both of these features, we're going to go ahead and establish a relationship and make them both concentric. Let's go ahead and fix that guy there and try that again. There we are. Let's try 0.25. That's pretty close. We'll go ahead and get this R drawn up. And there we are. And lastly, we will put this symbol on here. Straight line. There we are. We'll go ahead and add a couple dimensions on here, just so when we create a 2D drawing, you'll see the significance of this as compared to an older software like AutoCAD and how much nicer this is. So we'll go ahead and get out of this sketch and we will extrude it into a solid. Onto features. Let's go to the selected contours feature. I see, I have an error in my sketch. Let's go back and edit that real quick and close it up. There we go. See, the importance of a closed chain is critical to making a good watertight solid model. Let's say we're going to make this 1 inch tall. Maybe let's make it 3/4. So we're content with that. Got a bunch of multi-body things going on here. So let's create another boss from the same sketch. This time we want to select the other piece of the symbol. And let's offset it a bit. Let's make it go 1 inch. So there it is, but now we need a base, something to chuck up in the vise. One more time with this sketch. Let's reverse the direction. Now this is an important feature right here, merge result. If we do not select merge result, then you're going to have a bunch of multi-bodies, and that could create you some issues depending what you're trying to do. So if we want to just create one solid model, then this needs to be checked. So we do. Personally, I don't want to have that much material. Let's just make it 200 thousandths. This is good. And then you can, I believe, hold Control B and rebuild that. So you see that stock has gone down. And lastly, we better go ahead and do an extruded cut. Same sketch, selected contours. Do not want to forget this. There's one. There's the other. And we're not going that deep. Maybe there. Good, good, good. So now it's in. I definitely promised them that I would keep this logo as close as possible to national, of course. So let's go ahead and get the coloring correct. I'm going to change all of these faces to black. Yes, indeed. And then we're going to do it again for this face. I think this will look a lot closer by the time we pull this thing into Mastercam. Excellent. Before we do, let's go ahead and just show you how powerful and easy creating a drawing from an existing solid model in Mastercam or SolidWorks is. So you simply create drawing from part, as we've done. If you have an established title block or something like that, you know, your own drawing format, that's where you would pull it from. You simply just grab and go, and it gives you all of the you know, normal orthographic projections. You know, of course, you could scale them how you need to. You know, if you wanted to make that thing a solid here, or again, if you know, had some kind of a custom scale that deviated from standard, you know, you could change them all. You change some, right click. You know, if you needed to do a section view of this for some reason, you know, all of these tools are available. Now, going back to the dimensions, if you click Insert Model Items, what's really nice is any of the dimensions that you'd inserted during the design phase will populate immediately. I'm not going to mess with all the fonts and format. And notice that we didn't add many critical characteristics to this part just for the sake of presentation, but very powerful tools available to you in SolidWorks. What we'll do is we'll go ahead and get out of this and we'll save this file so we can go ahead and export and show you where the magic happens on the CAM side. So I just ran through this. This will call it live. Yes, we are. So we'll go ahead and get out of SolidWorks and we'll open up Mastercam. While this is loading, I'm going to go ahead and plug this charger into this computer so we don't have any issues. Laptop says 3 hours, but I think CAD CAM might consume a little bit more. Let's go ahead and file, merge what we just created. That was a SolidWorks file. Said it was live. Let's open that. We are pretty happy with where this thing lies. Go ahead and accept it. And the next thing we'll do while we're at it is merge in this Kurt Weiss that I had made up. I believe that was a step file. You could just hit all files and see everything that's in there, and it was. So yeah, this thing's coming in all out of orientation, which is fine. Give me a chance to show you some of the great functionality. You can go ahead and click this solid model. What's nice on this here quick menu up here is you can hit invert selection and it selects everything other than what you had selected. So with that, we'll go to transform, one of my favorite commands, dynamic. We'll do this a couple of times. I just want to get it in the general in the right direction. Let's see here. Goof that up pretty good. Let's try again. So you can just type in 180. That's what we want to do. And you notice how it's all purple. You can hit this quick mask command over here and it'll select the last things that were selected. We'll go ahead and do that dynamic again. We want to move this fixture to the part, not vice versa. So we'll start there. We'll put it right there. And then we will move it backward. Then we will give it the old eyeball and we'll move it along. Excellent. Maybe right there. There we go. So that way we're not going to hit the vise. Go ahead and clear these colors. So it's kind of burning my retinas. And we'll go ahead and get started with programming this thing. You can go ahead and toggle off these crosshairs by hitting Alt F9. You don't want to see them, or you can go to view, and they've got it right here. I prefer to see it myself. Before we go any further, I want to point out this right here. So this is a dynamic gnomon. You can create any work offset anywhere you want and orient it. Let's just assume for a second that we're going to set 0 at the base of this component, and we like X and Y on the corner right where you see it. And we'll just call this setup 1. And so we'll go to planes and setup 1. We want to equal everything out. And as you can see, that's where we're at. So now we need to go ahead and select a machine. It's going to be a mill. Let's just select the default mill. Oh my goodness, what have we here? I think it is. Hell, we'll just go with it. So we'll pick back up. Stock setup. No, it's been on the whole time. Yeah. That's all good. So there we have it. Got our stock model set up there. Now we'll go ahead and do 2D dynamic. Machining regions, that would be this one. Now we want to take a preview. It's going to cut this whole slab. That's not what we want it to do. We want to avoid certain regions, obviously. We do not want to cut all of that. Make a preview that again. That looks a lot better. So let's just pull open what they have available to us here. It ought to be a 1/2-inch flat end mill. There we go. And we'll just put in a note. This will pop up at the header of this operation. Let's just say rough op 1. We're not going to mess with any of the parameters, feeds, and speeds. You get that, from your tooling specialist who you buy it from, your distributor. Step over. Typically, it's less than that unless you're cutting aluminum or with a stabilizer or something like that end mill. We'll just keep that there. And we'll go ahead and take the stock off the floors, maybe make it a little more realistic, 7 thou on the walls. We'll keep all that the same. Linking parameters, I like to use a standard amount, say Z 2 inches. You can click all of this straight from the model. Depth, I like to use absolute myself, but it's not set in stone. So this 0.2, by the way, that's 0.2, if you'll recall, stock that we gave from the bottom of this surface. So that's where that comes from. And me personally, just to kind of crunch down on some of the code that comes about from this, I just do this here motions, and it makes a big deal. If you have an older machine, I wouldn't select that. You definitely want to verify whether or not your machine can handle 3D arc output. Otherwise, you have some very undesirable things happen, believe me. All right, so we got some toolpath going on, and we'll verify it all at the end. You'll notice that it doesn't come through all the way. So we'll just go ahead and copy that down. We'll come back in. And this time, we'll select a smaller diameter tool. Let's say, for instance, let's use a 1/4 inch this time. You know what? Let's use an 1/8 inch. That's not realistic. Obviously, you wouldn't want to do a bunch of roughing with that, but I think there's some pretty tight corners that'll make it difficult to get around. Now, since you have a previous op, you definitely want to have this selected so it sees the stock left over from those previous operations. And you can see now that it's dirty, it's got an X on it. So you can see we're selected here. We can either select that, regenerate all selected ops, which is just one, or, or you can do them all if you have multiple dirty operations. We'll go ahead and toggle that first toolpath off so we can see the second one. And we did break through on those regions, but not everywhere. Let's see, I guess I didn't slim it down enough. Let's make this, let's go ahead and make this diameter an 1/8 inch instead. Let's make this cutting length 1 1/8. Again, very unrealistic. I certainly wouldn't want to run that program, but this is just for the sake of demonstration. Let's see how that looks. By the way, when you see this symbol, that means your multi-threading manager is running. You can pull that open and actually see the progress of this high-speed toolpath as it's being created. Again, depending on what your step over and all the parameters are, I've seen this thing take a ridiculous amount of time to get through. So just bear that in mind. So all that looks pretty good. Let's go ahead and just run another 2D toolpath. And again, there's a lot more economical way of machining these faces. Obviously, they're down from the top face, but just to keep it simple. Also, we want to avoid this region right here. You can take a look at those chains. That's pretty good. We'll probably just go back to that 1/2" flat end mill and say facing up. We do not need this stock selection enabled. We will step over 50%. Nothing on the walls. Top of stock. The depth is here. We'll let it go. Face 2, 3, 4, 5, 6. There we go. So we've got all that done. Let's go ahead and add a finish pass in there. So just do a 2D contour. We'll select some of these chains. Go back to that 1/8" end mill again. Wouldn't want to finish that with this deep a depth, but that you select wear comp, that's going to put in a cutter comp, and the control will be a G41, G42 right there. And keep it left-handed. If you wanted to ramp or do anything like that, you could, but we're not. Lead in, lead out. Top of stock will be here. Depth will be down there. So you can see that we're on the inside of this chain, which is definitely what we don't want. Let's pull open this geometry and take a look at it real quick. So yeah, you can see that this thing right here is on the other side. We want to change the side of that one. And let's regenerate it. See, now it's going. Now, me personally, I don't like the conventional cut when I finish. So that thing really, you would also need to reverse the direction. On the wrong one, sure was. Let's reverse that. There we go. Let's try that out. on the inside again. There we go. There we are. And that's just a shank at the top of the tool. You can see that silhouette right there. We've got that quick verify on or off. You can toggle. Again, I'm on the inside of some of these tool paths. So let's take a closer, more careful look this time. Yeah. This one's good. This one is not. Change the side and reverse it. There we go. This one right here is the same case. We need to reverse it. It looks like that side is right now. Let's reverse that. You know what? We're just going to go ahead and get rid of these two. I didn't do a good job of chaining that to begin with. Let's add chain. That'll work. Now let's take all of this. Let's go into our simulator options. Select some fixtures here. Okay. And let's verify all this. Definitely want to stop on a collision. In this case, we'll stop on operation changes. Slow this down just a little bit. All right, so we goofed something up by leaving the skin all the way around there. Let's take a look at that real quick. So that's going to be this op. You can see that this tool path is not extended beyond the periphery of this part. We definitely want to see why that is. Well, here it is. It's because I've stayed inside instead of going outside on my strategy. Really, that's going to dirty everything up. So let's regenerate real quick. Let's come out to this facing op too. I noticed something real goofy happening right there. Perfect. All right, here we go. And this should be the home stretch. Now you see that we've gotten rid of that thin wall all the way around that outside edge since we adjusted that parameter. And now we've got it all knocked down. There's your finished model. One thing that's really neat too is that, you know, if you have something complex going on with a bunch of different fixtures and things that are really, you know, close clearance and that you're worried about, you can see this thing from a whole bunch of different angles. If you even wanted 4 views and you wanted to get fancy, you certainly could and see it from a bunch of different angles. Also too is that you could come in here and actually record straight from this and you know, send it to a customer or send it to your, you know, production department or whomever you need to share it with. This is certainly a nice way to you know, simulate the work being done before proceeding. I've used this to send to prospective customers as to which way I would process their parts, you know, which is really nice. I think it's a nice feature that Mastercam added in. So anyway, I know we've gone well beyond time. Had some difficulties along the way. Hopefully we edit that out and you never knew about them. So thank you very much for your time today, and look forward to learning with you in the future.